All right, I'm going to go ahead and start talking through these. Right, with the first problem, again, your options are to use trial and error, reverse FOIL it, or to rewrite the middle term. If you're going to use trial and error, when you look at the possible factors for this, the first factor is a prime, the coefficient, leading coefficient is a prime number. So when you look at what two products, or what two factors can give a product of 5x squared, the only option you have is 5x and x. Okay, so 5x and x have to be the first terms of this. Now, when you look at your last terms have to have a product of -6, and then the outer plus inner terms have to equal -13. Okay, so let's take a look at all the possible factors of -6. So you can have a +1 and a -6, a -1 and a +6. You can have a +2 and a -3, -2 and a +3, a +3 and a -2, a -3 and a +2, or you can have a +6, -1, or -1, +6. So here's, a -6 or +1. So here are all the possibilities that you need to kind of check if you're going to do trial and error. Well, you can eliminate some of these by looking at the problem. You know that the total sum of the outer and inners has to be -13, so you're probably going to multiply your number on the far term by this outer 5. So you're probably going to have a negative on this outer term. So we can eliminate any of these ones that have the positives to the right. And so that cuts it in half. So now we only have 4 possible combinations to test. And so let's test the outer and inner sum. So our outer is -30x plus 1x. Does that equal -13x? No. So move to the next one. -15 plus 2. Does that equal -13x? Yeah. So in this case, we were able to find it within 2, trial and error. Okay, so if you're going to do it that way, that's one of your possibilities. And my suggestion to you, though, is to not waste time. And the way that you can do that is just make sure that all the work that you do is always going to lead to the correct answer. And that's by rewriting the middle term. So if you did this by rewriting the middle term, you take your leading coefficient times your constant. 5 times the -6 is -30. And we're going to look to see, are there any factors of -30 whose sum is -13? 15 and +2, right? And now if you're thinking -10 and -3, that has a product of +30, so that's not going to work. So you need two numbers whose product is -30, whose sum is -13. So we can rewrite our middle term, drop the first and last terms down, and then factor by grouping. So from this first set of terms, we can remove a common factor of 5x, leaving an x minus 3. From the second set of terms, we can remove a common factor of 2, leaving an x minus 3. We have a common binomial factor, which we can pull out. And then the remaining factors of 5x and +2 become the terms of our other binomial factor. And so we wind up with the same solution as if we had done by foiling, or reverse foiling. Okay. In this next example, I'm going to go through, it's the same idea, almost everything's the same. The only difference is this last term is a positive, and then the last 2 terms contain the y's as well. So let's take a look at our reverse FOIL, trial and error process. Again, our first terms have to be 5x and x. There's no other possibilities. Our last terms now, we need a product that's positive. That means the signs are going to be the same. They're either both positive or both negative. And we need a sum of outer and inner products that is a negative. So that tells us we only need to consider the negative combination. So we have to look at -1, -6, -6, -1, -2, -3, -3, -2. These are the only possible combinations for this. So we can go through and test these. We want our outer plus inner products to equal -13. So -30 minus 1x, not going to work. -5x minus 6x, not going to work. -15x minus 2x, not going to work. -10x minus 3x, we found the one that works. It was the fourth trial and error on here. So we get our answer to be 5x minus 3 times x minus 2. Okay, so once again, if you want to or are able to solve this using the strategy of rewriting the middle term, it may be more efficient to do it that way. And if that's the case, we're going to take our product of the leading coefficient and our last term's coefficient. So 5 times 6 is positive 30 this time. So what two factors of positive 30 give you a total sum of negative 13? Now you have your negative 10 and negative 3. So if we rewrite our middle term as the sum of those, drop our first and last terms down, including the y's, all the variables. Okay, when we look at the first pair of terms, we can remove a 5x, leaving an x minus 2y. From our second pair of terms, we can remove a negative 3y, leaving a positive x and a negative 2y. We now have this common binomial factor, which we can remove, x minus 2y, and the remaining factors of 5x and negative 3y become the terms of our other binomial, 5x minus 3y. And again, it confirms what we got up here, which again, we would need to add our y's in when we wrote our factors. Okay, but you can do it whichever way works for you. Again, I'd invite you to use the rewrite the middle term. It's a little more efficient. Go, sir. On that, the reason you couldn't is the signs have to be the same on this one because the product is positive, yeah. All right, for problem C, I'm going to show you two different ways to solve this. Again, I'm going to show you if you look to rewrite the middle term first, and then I'm going to show you a simpler way after that. Okay, so in this one, if you look to rewrite the middle terms, you take your leading coefficient times your constant, you get a negative 45. Are there two factors of negative 45 whose sum is negative 12? Well, it's the ones that are given, right? The 3 and the minus 15. So minus 15 and a positive 3. Rewrite our middle term as that sum. Then factor by grouping. In the first pair of terms, we can remove a 3x. When we do, we're left with an x minus 5. From the second pair of terms, we can remove a 3, again leaving an x minus 5. So we can pull out that common binomial factor, x minus 5. Take the remaining factors of 3x plus 3. Those become the terms of our other binomial. Now, what do you notice, though, about this factor? Is that completely factored yet? No. So what can we remove from this? So we take that out and we put it in front, a 3. The x minus 5 will stay as it is. And this, when we remove a factor of 3, becomes x plus 1. And so that is our solution in factored form. Okay. Now, I mentioned I'd show you an easier method for this. The very first thing that you want to do anytime you're looking to factor is what? What's the first step? Simplify meaning remove common factors, right? Is there a common factor you can remove from all three terms in this original expression? 3. So if you had been able to see that and remove a common factor of 3 first, you'd get an x squared minus a 4x, and then minus a 5. It becomes an expression that's factorable with a leading coefficient of 1. So all you need to do is look for your binomial factors. What two factors of negative 5 have a sum of negative 4? Negative 5, positive 1. So it would have been easier had you seen to remove the common factor first than even rewriting the middle term. All right, the last example. A couple things that you should kind of go through step by step. First, look to remove common factors. There are none. The next thing, though, that you want to notice is you have a 9y squared and a 4. You have perfect squares on the outsides. So you may want to consider testing it for one of the special factor forms. The one thing that blocks that, or that you should notice here, is our last term isn't being added. In any of the perfect square trinomials, you need to have a positive perfect square at the end, so we don't need to consider the binomial square either. So we can go right into either trial and error or rewrite the middle term. So if I use the process of rewriting the middle term here again. So I take my leading coefficient times my constant. 9 times a negative 4 is negative 36. What two factors of negative 36 have a sum of positive 9? Negative 3, positive 12. So if we rewrite our middle term as though sum, drop down our first and last term, factor by grouping. We can remove a 3y as a common factor from the first pair, leaving a 3y minus 1. From the second pair, we can remove a common factor of 4, leaving a 3y minus 1. And now we have a common binomial factor that comes out. The remaining factors of 3y and a positive 4 become the terms of our other binomial. Okay, so we're able to solve those relatively quickly.